Hello, and today I'm going to talk about phase changes. Hello, today's lesson is going to be on phase changes. Now, there are three states of matter that you need to be able to identify with. Hello, today's lesson is on phase changes, so let's get started. Now, to review, there are three phases of matter that you need to be aware of. They include solid, liquid, and gas. What is a phase change? Well, it is a change from one state of matter, solid, liquid, or gas, to another. There are some cases where plasma is involved, but we'll get into that discussion later. Phase changes are physical changes because it only affects physical appearance and not the chemical makeup. In fact, they are reversible when we're talking about phase changes. Now, physical changes. Matter is always changing form, size, shape, color, etc. There are two types of changes that matter undergoes: physical or chemical change. Physical changes occur when a change in matter changes without its actual identity changing in terms of the substance. In other words, a change in state, a change in size, shape, or mass does not change the chemical makeup of matter, and you have what you started with just in a different form. That is a physical change. Now, there are some examples included in the images. They include torn paper into pieces, sugar dissolved into tea, salt dissolved into water, or even nails that are being trimmed or cut. Now, there are examples of phase changes. We're going to go through these and talk about how energy impacts these changes. Now, please understand as we go through this presentation that phase changes are physical, not chemical changes. The types of phase changes include melting, freezing, evaporation, condensation, sublimation, deposition. And of course, all of these phase changes are caused by either adding or taking away energy. So you'll want to be aware of how energy is impacted during this process. So what happens during a phase change? Well, during a phase change, the heat energy either is absorbed or released. Heat energy is released as molecules begin to slow down and move closer together. During absorption, the molecules begin to speed up and begin expanding. Now, matter changes from one state of matter to another, either when heat energy is added or when heat energy is taken away. Before you is a diagram that kind of highlights these phase changes that we mentioned, and as we go through, we'll kind of look at how energy impacts these processes. Now, the first thing you want to do is make sure that you draw this diagram in your notes. It includes the phase changes that were mentioned. Notice that some of these phase changes are reciprocal or kind of partners, if you will, of one another, especially when you're talking about going from two states of matter. Melting. Melting is pretty much a staple of understanding. The example in the image shows ice cream melting. Basically a phase change from a solid to a liquid. The molecules speed up, move further apart, and absorb heat energy, meaning energy is added. Freezing. This occurs as a phase change from a liquid to a solid. During this process, the molecules slow down, begin to move closer together, and release heat energy. Energy is released or removed. Vaporization, boiling. This phase change is from a liquid to gas. It occurs at the boiling point of matter. Molecules speed up, move further apart, and absorb heat energy or add it. Evaporation. Phase change from a liquid to a gas on the surface of a liquid. This occurs at all temperatures. Molecules speed up, they move further apart, and begin to absorb heat energy. Condensation. Phase change from a gas to a liquid. The molecules slow down, move closer together, and they release heat. Energy is therefore removed. Sublimation. This is a phase change from a solid to a gas. Notable examples include dry ice, and during sublimation, you have molecules speed up, move further apart, and absorb heat energy. Energy is added. Deposition. Although not as quite common in the South, it's a phase change where you go from a gas to a solid. In this case, the molecules slow down, move closer together, and begin to release heat where energy is removed. Vaporization. There's an important note that you need to know. You need to remember that vaporization is a general word for any substance changing to a gas. So it can apply to both evaporation, boiling, and sublimation. So all of these are notable examples of vaporization. Now before you is a diagram of the phase changes, and what you should notice is that this highlights the process of energy being added, as well as two key vocabulary words we'll kind of earn or add to our repertoire if we haven't already, which include boiling point and melting point. There's another one that probably should be listed, but you'll kind of be able to deduce the definition as time progresses, and that's freezing point. And so at these various lines and junctures, you notice that the temperature remains the same at those particular point or instances of changes. There's the melting point, which transitions from one state of matter to another, and you have the boiling point where there's a transition. So you want to keep that in mind as you interpret understanding a graphed phase change. Here's an example of melting and freezing of water. We know that water usually freezes at 0, and it's a graph with respect to temperature and time. And so over time, it shows how there's an increase in temperature, eventually hitting one phase. The plateau is where the phase change actually occurs. And so during that, when you have the diagonal lines, it's showing just the temperature change. And when there is that static plateau, that's just the actual phase change of melting, freezing, etc. So there are a few questions. Why is there no change in temperature during a phase change? Can we define melting and boiling points? What is the melting point and boiling point of water? At what temperature does water freeze and become a solid? Well, for water, there are a number of pieces of information that we should kind of be able to glean from this image. Well, water freezes at 0 degrees. Water begins boiling above 100 degrees. There is no change during this phase change process because at this highlights how there's a transition from one state of matter to another state of matter. And between this process is going back and forth until it reaches that full transition into the next state of matter. Now, to define melting point, it is represented by the temperature at which a solid changes into a liquid. Boiling point, the temperature at which a liquid changes into a gas. What is a freezing point? Compare the freezing and melting points of water. Let's think about that. Freezing point could be similar to the definitions of boiling and melting point, with the distinction being the point at which it's turned into a solid. Now, this summarizes those images that I've talked about. Notice the arrows highlight where energy is released when you're talking about the processes, and it highlights where heat energy is also absorbed. The main thing with understanding phase changes is that there is a change of state of matter, and there's a certain amount that's specific to that compound of energy released or absorbed. And depending on that compound, that amount of energy that's released or absorbed can vary. This completes our presentation on phase changes.